Hello, my name is Emanuel Sachs, and I'm delighted to have the chance to tell you about a project that my students and I are working on. The project is called 3Draw, and the goal of 3Draw is to provide a computer-based tool that is ideally suited to the initial stages of conceptual design. Our vision is that designers and industrial designers will use 3Draw to think out their ideas, in preference to the pencil and paper that they now use. The basis of 3Draw is the idea of communicating three-dimensional shape directly in 3D using the relative motion of the two hands. We were inspired in the development of 3Draw by this photograph of Picasso painting in the air with a flashlight. The freedom of expression that this photo captures on film is now captured electronically with 3Draw. During this video, you will meet Andy Roberts and Dave Stoops, the two students who are developing 3Draw as their master's thesis. The team is happy to acknowledge the collaboration of Professor David Gossard, director of the MIT CAD Lab, where this work is being done. We are also grateful to George Selniker, whose PhD work we will refer to during the video. Our frequent discussions with Dr. Todd Seiler and Professor Carl Ulrich also help to shape our work. Let's take a look at how 3Draw works.
Hello, my name is Andy Roberts. I'm going to use 3Draw to sketch an automobile fender, but first let's take a look at 3Draw's user interface. In my left hand I'm holding a tablet which corresponds to three-dimensional objects in the virtual world. In my right hand I'm holding a stylus which corresponds to a three-dimensional drawing and editing tool. Together these sensors allow me to create three-dimensional objects directly in 3D. As I move the tablet side to side and the stylus back and forth, notice that the motion in the virtual world is the same. Another component of 3Draw is the source and the main unit. The magnetic field generated by the Polhemus source is used by the main unit to measure the position and orientation of the two handheld sensors in real time and send this information to the Silicon Graphics computer. Now let's take a look at 3Draw in action. To begin the car, I'm going to draw a freeform line that represents the base fender. Once this line is drawn, notice that it snaps to the object so that I can move it with my hand. I'm going to use Translate to move the line out towards away from the center of the car. And now I'm going to use the ball and socket function to grab the end of the line and move it as though the other end were attached to a ball and socket joint. The next step of this process is to erase a section of this line using Erase Point and clicking on points in order to erase sections of the line. Now that I've opened a section of this line, I'm able to pick 2 points and draw a freeform line that attaches these 2 points and represents the wheel well. Once this line is drawn, I'm able to twist the stylus to obtain the proper orientation of this new line through the endpoints. When I obtain the proper orientation, I just drop it off by clicking the stylus. The next step is to pick a point near the front of the car and purposely not pick a second point so that I can draw a freeform line that attaches itself to that one point and lets me pick the position and orientation of the other end with the stylus. This line I'm going to drop off first in an arbitrary position and use ball and socket to more finely position the end of the line. Both horizontally and vertically. Now I'm going to use axis twist to twist this line through its endpoints. These functions are nice because I can use them separately without changing more than just the twist of the line, in this case, at one time. The next step, I'm going to take a point on the hood and a point on the base of the car and join them with a sweeping line representing the side body. And again, this line is able to pivot through the endpoints until I drop it off. Another line is going to be from the hood in the middle of the car to the top of the fender well. And this line snaps into position and allows me to twist it through its endpoints. The next step will be to erase two sets of ends of lines to clean the model up. And as a final step, we're going to reflect this whole half of the car through a central reflection plane using reflect line. You see that a purple reflection plane appears on the screen, and I'm able to just click on the lines that I've created so far in order to create mirror images through this reflection plane. Using this, I'm able to very quickly generate the symmetrical other half of the car. And as a last step, I'm just going to join the left side of the car with the right side of the car with a single line through the two highlighted points. In this relatively short time, I've created a wireframe three-dimensional model of a fairly complex part. Now let's take a look at some more complex models that we've created in the past. This is a more complete model of an automobile body that took about 45 minutes to create. Notice that it's convertible and it contains quite a few three-dimensional lines near the back of the car. I can move it with my hands into a number of different orientations. Here I'm showing a top view, and I can move down into a forward view just by moving my hands in a similar manner. This is a model of a 12-meter yacht that took roughly an hour and a half to create. It has nearly 100 lines in it. As I bring it up towards us and turn it, notice that down the center of the boat there's a central symmetry. I use the reflection plane to create that. And the winged keel contains a number of three-dimensional lines that you can see as I turn the model. Now as I turn the floor on, notice that I'm able to put the boat down and simulate how the boat would move if I put it in the water.
I'm Dave Stoops, and I've been co-developing 3Draw since July of '89. I'm going to demonstrate a few of the curve deformation tools that we've built into 3Draw. I'll start by drawing an arbitrary curve in space. The first tool I'd like to show is called the force gun. It's represented on screen by a blue cone. As I move the cone, I can intersect portions of the curve that I just drew. Pressing the stylus button now turns the cone pink, and the points within the cone are displaced as if by a force emanating from the pen tip. Smoothing is a function that we often use to get fair curves. The technique used was developed by George Selnicker of the MIT CAD Lab and uses physical modeling software. I'll start by pre-selecting 2 points to localize the effect of the smooth. If I press the stylus button now, the portion of the curve within the points is smoothed out. The last tool I'd like to demonstrate is the tweezer. The point closest to the pen tip can be grabbed and yanked around by the stylus action. This tool is very interactive, so we can obtain multiple points of view while deforming the curve.
As we have seen, 3Draw can be used in a natural way to design a 3D shape, using motions of the hands as the communication medium. We have seen 3Draw used to create lines and to edit lines in space. In the future, we will be able to fit surfaces to our lines and to modify those surfaces to their final form. Another improvement will be the use of a stereoscopic display, which will enhance the user's interaction with the displayed model. We believe that 3Draw embodies a new paradigm for shape design, which liberates the designer from the limitation of 2D tools. Thank you very much.